In this video, I'm going to focus on solving quadratics using factoring and the square root method. I'm going to start by doing examples for number 3 and number 4. The first thing that I need to think about is if I'm set equal to 0, and you can see right here that we are, and then I'm going to look for the greatest common factor to see if there's anything that can divide out of everything. And in this case, we can divide a 5 out of both terms and an x out of both terms. So that's the first factor I have is 5x, and then I look to see what would be left over after dividing that out. And for my first term right here, the 5's would cancel, and one of the two x's would cancel. So I would have x left over minus, and here only 5 would be left over. And of course, it's still equal to 0. Now I have two factors that multiply to 0, which means I would have each factor set equal to 0. And my first equation, 5x equals 0, I could divide both sides by 5. 0 divided by 5 is still 0. So that's one of my answers. And then the x minus 5 equals 0. I have to add 5 to both sides in order to cancel out the minus 5 or the subtract 5. And I would get x is equal to 5. So my two answers would be 0 and 5 that I would write on my line. Now I'm looking at number 4. I have x squared plus 7x plus 5 equals negative 5. This is a problem. We need it to be equal to 0 in order to use the zero product property. So the first thing I need to do is to add 5, because minus 5 plus 5 equals 0. And if I do it to one side, I have to do it to the other. And I'm going to align it under my like terms. So I have x squared plus 7x plus 10 equals 0. Now I'm ready to factor. And my next step here is to look for greatest common factor, and there is no common factor. If my leading coefficient is 1 and this doesn't have an x, I know that there is no common factor other than 1 that can divide out. So I'm ready to do a times c. And for a times c, I have 1 times 10, because my a comes from my leading coefficient and my 10 is my constant. 1 times 10 is 10, so then I'm looking at factors of 10. 1 and 10, 2 goes into 10 5 times, 3 doesn't go in, 4 doesn't go in, and then I'm back to 5. So I'm looking for positive factors because I'm trying to add to positive 7, and 2 and 5 add to positive 7. So if I make my box, and I have here x squared plus 7x plus 10 goes across my diagonal. And now I know that to split that up, I want it to be 2x and 5x. That's how I want my 7x split up. Remember that these two corners need to add to my middle number right here. And now I'm looking for the greatest common factor of each row and each column. So in my top row, x can divide out, and in my bottom row, 2 can divide out. In my left column, x can divide out, and in my right column, 5 can divide out. And you want to always double check this by multiplying. So x times x gives me x squared, which is what I have right here. X times 2 gives me 2x. 5 times x gives me 5x. 5 times 2 gives me 10. So I know that I multiplied this correctly. I have the right factors. And so I'm going to write those factors. I'm going to replace my standard form with factored form. So I have x plus 2 and x plus 5, and those are equal to 0. And because a product equal to 0, each of those factors would have to equal to 0. I'm going to write those little mini equations, and I'm going to solve each of those mini equations. So if I have x plus 2, to get rid of the plus 2, I'm going to subtract 2, which gives me an answer of x equals negative 2. If I have x plus 5, to get rid of the plus 5, I'm going to subtract 5 on both sides, and I get x equals minus 5. So these are my two answers. Remember that I could check by plugging each of these values into my original equation and seeing that I equal negative 5, which is what I had in my original equation. So either one of these x's should be able to be plugged in to get that answer to start with. Always a good idea to check, especially if you're uncertain. Remember, for simplifying radicals, we want to look at our multiplication table and look along the diagonal to see if it's a perfect square first. So for example, on 36, if I'm looking at the diagonal of my multiplication chart, I do see 36 at 6 and 6. So I know that this is a perfect square. And It's because 6 times 6 is 36. The square root of 36 is 6. For the next one, 40, if I look along the diagonal, it is not there. I see 36, and then I would see 49. 40 is not between there. So I know that I need to do my factor tree. So 40 divided by 2 is 20. 20 divided by 2 is 10. 10 divided by 2 is 2 and 5. And so I'm looking until all of my ends of my branches are prime numbers. 2 times 2 times 2 times 5 all multiply to be 40. So I know I've done this correctly. And then I'm looking for pairs. So I see that I have a pair right here, and that's the only pair at the end of my branches. So remember, what we do is we write our pair under one radical, and then everything else at the end of our branches, which is a 2 and a 5, is in a different radical. So I have the square root of 10 here, and this is the square root of 4. Square root of 4 is on our diagonal. That's why we did this process. The pairs make a perfect square. So square root of 4 is 2. We know the square root of 10 does not simplify because it has two factors that are prime. And so our final answer is 2 root 10. And you will do that for those other two problems. Quick reminder, for factoring, we need it to equal 0 before we can factor. And for simplifying, remember to look at your diagonal along the multiplication table first. Now flip to the next side. For these problems, we are going to be using the square root method. Remember, for a square root method, there can be no x term, so just an x squared, no other x. And we want to not get it equal to 0, but get the x squared by itself before we can square root both sides. We'll start looking at this question number 12 here. 5 times the quantity x plus 2 squared equals 500. We're trying to get the x squared term by itself. So we're trying to get this whole thing by itself, which means we need to get rid of the 5. It is attached by multiplication. So we're going to undo that multiplication by dividing by 5. That is x plus 2 squared that's left over on the left side because that cancels out. And 500 divided by 5 is 100. Now I have just the x squared by itself, like just this whole thing is being squared. So to undo a square, I square root it. And if I square root it on one side, I have to do it on the other. And remember, when I square root, it gives me two answers, a plus and a minus. So I always want to add that right when I square root, just so I don't forget. And on the left side, the only thing that's left is my x plus 2 because the square root undoes the squares. It basically cancels that out. On the right side, I have 100. I want to look at my diagonal on my multiplication chart and recognize that 100 is a perfect square. And so the square root of 100 is just 10. And I have both a plus and a minus 10. And I'll talk about how we're going to simplify that in a minute. We're going to still treat this like a regular equation. Now I have x plus 2 over here, and I'm still trying to get just what x is. So to get rid of a plus 2, I'm going to subtract 2. So I have x equals this minus 2, but I still have a plus and minus 10. What that is it basically gives me two different equations to simplify, or answers to simplify. I have minus 2 plus 10, which is equal to 8, and I have minus 2 minus 10 for the plus and minus 10, and that is equal to 12. So I have two answers here. I have a positive 8 and a negative 12 that if I plug into my original equation will make a true statement. Let's also take a look at 13. And we're trying to get this x squared by itself. So just like you're solving if this was just an x equation, we would want to get rid of the minus 1 first. So I'm going to add 1 to both sides. And I have 3x squared equals negative 18. And I'm still trying to get that x squared by itself. I got to get rid of the 3. That's a times 3. So to get rid of that, I would divide by 3. So now I have x squared equals negative 6. And now I have the x squared by itself, so I can square root both sides. And I don't know if we've talked about this yet. And so if we try to square root of negative 6, if you put the square root of negative 6 in your calculator, you're going to get an error message. We cannot square root a negative number. It comes out to be an undefined answer because nothing times itself is going to produce a negative answer. So cannot square root a negative. And what we say when that happens is that there is no real solution. That just means there's no number that we could plug in to this in our equation that would make this a true statement. So there's no real solution for this because we cannot square root a negative number. The process for all of these is the same. You want to get the x term, the x squared term by itself, and then square root both sides and simplify. You will have to do some simplifying of radicals like we practiced on the previous page.